All right, welcome back. Today, we're going to talk about a Python feature that will just instantly make your code look and feel more professional. I'm talking about the @property decorator. It's really the secret to writing classes that are cleaner, safer, and just way more intuitive to use. Let's get right into it.
You ever write a Python class and you just get this weird feeling like you're writing Java from 10 years ago? You're making all these extra methods just to get a value or set a value, and it feels clunky, right? It just doesn't feel like you're writing Python.
And this right here, this is the whole game. This is the before and after that we're talking about. On the left, you've got that clunky old way with the method calls. On the right, clean, simple, Pythonic. You see how it just looks like you're accessing a variable? But behind the scenes, there's all the power of a method. That's the magic we're going to unpack.
So yeah, let's formally introduce the villain of our story today, the classic getter and setter pattern. Now, look, this approach is totally normal in other languages like Java or C#, but in Python, it kind of feels like showing up to a backyard barbecue in a full tuxedo. It works, I guess, but it's just not the right vibe.
And why isn't it the right vibe? Well, a few big reasons. First, it is so verbose. You're writing 2 whole methods for every single attribute you want to manage. Second, it just clutters up your code with all these extra parentheses and get underscore this and set underscore that calls. And really, the most important thing is that it goes against the whole spirit of Python, which is all about simplicity. It's just not Pythonic. So what's the hero that comes in to save the day? It is, of course, the @property decorator. This is Python's elegant built-in answer for managing access to your attributes without making your code a total mess.
So what is it exactly? Well, @property is a special kind of function called a decorator. That's what the little @ symbol means. And you can think of a decorator like a wrapper that gives a function extra powers. In this case, it gives our method the superpower of pretending it's just a plain old variable.
I'm going to say this again because this is the perfect way to think about it. It looks like a variable, but it works like a method. When you type student.name, you're actually calling a function, but you don't need the parentheses. It's just a brilliant piece of design that makes the code so much cleaner to read and write.
Okay, that's enough theory. Let's see this thing in action. We're going to build a really simple student class and add these properties one by one, so you can see exactly how the whole thing comes together.
But first, we need to talk about a super important convention. We're going to have 2 things: name, which is the public property everyone will use, and underscore name, with a leading underscore, which is our internal storage variable. That underscore is a big signal to other developers that says, hey, you probably shouldn't touch this directly. But more importantly, it stops us from creating an infinite loop. Think about it. If our name property tried to access self.name, it would just call itself forever. By having it access self.underscore name, we break that cycle.
Okay, step 1. Here's our init method. It takes a name and tucks it away in our internal variable self.name. Then, look right below it. We define a method also called name, and we pop that @property decorator right on top. All this method does is return self.name. And just like that, anyone using our class can just type student.name, and this method runs behind the scenes. Simple.
Okay, so we can get the name, but what if we want to change it? Well, that's where the setter comes in. We create another method, and we call it name too, but this time the decorator is @name.setter. That @name part links it directly to our original property. This is our gatekeeper. This is where we can put our validation logic.
So let's trace what actually happens. When your code says sname equals Sarah, Python doesn't just jam that value into a variable. Nope. The @name.setter decorator sees that assignment and intercepts it. It takes Sarah, runs it through your validation logic, like making sure it's not an empty string, and only if everything checks out does it update the internal self_name variable. It's control and safety completely hidden behind a beautiful, simple interface.
So we've totally mastered the basic getter and setter, but properties are way more flexible than that. Let's look at a couple of other really powerful things you can do with them. What if you have something that should never, ever change after it's been created, like a student ID number, for example? Well, with properties, this is ridiculously easy. You just don't make a setter. That's it. If you only have the @property part, the getter, and someone tries to assign a new value to it, Python will just raise an error. It's a super elegant way to create read-only attributes. Now this is where properties get really cool.
A property doesn't have to be tied to a single internal variable. You can create what are called computed properties that calculate their value every single time you ask for them. So, for example, a full name property could just combine underscore first name and underscore last name on the fly. It looks and acts like a piece of data, but it's always up to date, and you never have to worry about updating it yourself. It just works.
All right, you're armed with a powerful new tool. Now let's just make sure you use it right. We're going to quickly go over some best practices and, more importantly, some of the common mistakes that a lot of people make when they're starting out.
So these are the big traps to avoid. The number one mistake is causing that infinite loop we talked about by calling self.name inside the name property itself. Always, always, always refer to self_name inside your property methods. And another big one is putting your validation logic only in the init method. Put it in the setter. That way the data is checked every single time it changes, not just when the object is first created.
So when should that little light bulb go off in your head to use @property? Well, here's your checklist. Definitely use it when you need to validate data. Use it when you want to give people a clean, simple way to use your class. And, this is a big one, use it when you think the logic for an attribute might get more complicated later. This lets you add that logic in the future without breaking everybody else's code who's using your class. It's fantastic for future-proofing.
Okay, let's bring it all home. Why did we spend all this time on @property? What is the actual tangible payoff for doing things this way?
The payoff is huge, honestly. You get code that's just cleaner and more intuitive to read. You get data that's safer because it's been validated. You get massive flexibility to change how things work under the hood later on. And frankly, it's one of the hallmarks of professional, well-written Python code. This is what it means to be Pythonic.
And look, don't just take my word for it. This isn't some weird, obscure feature that nobody uses. This is how the pros do it. If you peek under the hood of huge frameworks like Django or FastAPI, or any professional-grade AI library, you will see properties being used all over the place to create these powerful yet simple APIs.
So let's wrap it up. @property lets a method act like a variable. It's the clean, Pythonic way to control access to your data. It's your ticket to easy validation, read-only attributes, and those awesome computed values. Bottom line, it is the modern, correct way to replace old-school getters and setters in Python. Period.
And that's a wrap. So I'll just leave you with this question to chew on. Now that you've seen how to swap out this one old habit for a much better, more Pythonic solution, what other parts of your code could use that same kind of thinking? Thanks so much for watching.